Introduction. Renowned physicist and co-founder of string field theory, Michio Kaku, has always championed the potential of space exploration and its astonishing revelations for humanity. In light of recent advancements, Kaku has drawn attention to NASA's compelling discoveries on Mars, with one revelation taking center stage: the discovery of water, a vital component for life as we know it. If you think Mars is just a barren and desolate planet, think again. Here are 10 remarkable discoveries that have transformed our perception of Mars, revealing a world full of intrigue, mysteries, and the tantalizing possibility of life. Water, an element so abundant on our blue planet, is a precious and elusive resource in the vastness of space. Discovery of water. The discovery of water on Mars, therefore, shook the foundations of our knowledge and sparked excitement about the planet's history and its potential for hosting life. Through the use of advanced imaging techniques and the tireless work of rovers like the Mars Reconnaissance Orbiter, Curiosity, and Perseverance, scientists have uncovered compelling evidence of liquid water in Mars' past and significant amounts of water ice in its current state. Initially, these findings were based on the detection of specific minerals, such as hematite and gypsum, which typically form in the presence of water on Earth. In recent years, the introduction of cutting-edge ground-penetrating radar tools, like the Mars Advanced Radar for Subsurface and Ionosphere Sounding (MARSIS), aboard the Mars Express spacecraft has provided even more direct evidence. Thanks to MARSIS, scientists have made astonishing discoveries, revealing wide swaths of underground water ice reservoirs and even a subglacial lake reminiscent of those hidden beneath Earth's polar ice caps. These findings emphasize the ever-evolving and complex nature of space exploration. The presence of water on Mars serves as a testament to the planet's potential for hosting life and reminds us of the vast unknowns that lie ahead as we continue to explore our solar system. Each new discovery serves as a stepping stone, illuminating the path towards future exploration and the potential habitation of Mars. Methane, a puzzling clue to Martian life. In recent years, the presence of methane on Mars has captured the attention of scientists, igniting excitement about the possibility of life on the red planet. Methane, a simple organic molecule, holds significance because on Earth, the majority of methane in our atmosphere is produced by living organisms. The Curiosity rover, a stalwart explorer of Martian terrain, reported significant methane spikes in Mars' atmosphere that varied with the seasons. Equipped with a suite of advanced scientific instruments, including methane detectors, the rover provided detailed chemical analyses, unveiling fascinating insights. The levels of methane on Mars were found to oscillate between 0.24 to 0.65 parts per billion, peaking during the Martian summer. To explain the origin of this methane, scientists have proposed several theories. One possibility is that geological processes such as serpentinization, where water reacts with olivine minerals, release methane into the atmosphere. Another hypothesis suggests that ancient methane, trapped in Martian ice cages called clathrates, periodically escapes due to temperature changes. However, the most intriguing prospect is the potential for biological sources. Just like on Earth, microorganisms might be responsible for producing methane on Mars. The dynamic and diverse Martian weather. Mars, often imagined as a static and desolate red desert, has proven to be a planet of diverse and complex weather patterns, challenging our previous assumptions. Thanks to the collective efforts of NASA's numerous rovers and orbiters, we have gained valuable insights into the ever-changing climate of the red planet. The Mars Atmospheric and Volatile Evolution (MAVEN) mission in particular has shed light on how the Martian climate changes with the seasons. Instruments aboard the Mars Reconnaissance Orbiter (MRO) and the Mars Climate Sounder have also provided crucial data about daily and seasonal weather patterns on Mars. Contrary to popular belief, Mars experiences a range of weather phenomena, including dust storms, frosts, and rapidly shifting atmospheric conditions. The planet's polar ice caps, composed of carbon dioxide, undergo a cyclic growth and retreat similar to Earth's polar ice caps. Mars is home to the largest dust storms in the solar system, engulfing the entire planet for months on end. Frost and snow have also been detected on Mars, adding to the planet's weather complexity. Whirlwinds known as dust devils, far larger and more common than their earthly counterparts, dance across the Martian landscape. Temperature fluctuations are extreme, with daytime highs reaching 20 degrees Celsius and nighttime lows plunging to a bone-chilling -73 degrees Celsius. Unusual Martian geology. Mars has captivated scientists with its unique and awe-inspiring geology. Orbiters like the Mars Reconnaissance Orbiter and the Mars Express have provided high-resolution images of the planet's surface, revealing massive volcanoes, deep canyons and ancient impact craters. Olympus Mons, the largest volcano in our solar system, stands at a staggering height of 13.6 miles, 22 kilometers. Mars' Valles Marineris Canyon system stretches over 2,500 miles, 4,000 kilometers, dwarfing the Grand Canyon. Additionally, the discovery of tridymite, a mineral not found on Earth, has puzzled researchers and led to re-evaluations of Mars' volcanic history. Signs of past life. The search for signs of ancient life on Mars has been a primary focus of numerous missions. NASA's Curiosity rover, which landed in Gale Crater in 2012, has made significant discoveries in this regard. It found organic molecules including complex hydrocarbons in ancient rocks, suggesting that Mars may have once harbored the necessary conditions for life. Additionally, the rover detected seasonal fluctuations in methane levels, which could be indicative of biological activity, although other non-biological processes could also be responsible. While definitive proof of past life on Mars is yet to be found, these findings support the hypothesis that Mars was potentially habitable in the past. Ice reservoirs on Mars. The discovery of extensive ice reservoirs on Mars has revolutionized our understanding of the planet's history and future exploration. Polar ice caps, composed primarily of water ice, were known for some time, but recent observations indicate the presence of vast underground ice deposits as well. These subsurface reservoirs, located in various regions of Mars, contain significant amounts of water ice. Accessible water is crucial for sustaining human missions and potential colonization efforts, as it can be used for drinking, growing plants, and producing rocket propellant. The Marsquake phenomenon. InSight, a NASA mission that landed on Mars in 2018, aimed to study the planet's deep interior. It successfully detected Marsquakes, seismic activities analogous to earthquakes on Earth. These Marsquakes provide valuable insights into Mars' internal structure, such as the thickness of its crust and properties of its mantle and core. By studying the propagation and characteristics of these seismic waves, scientists can better understand the planet's geology and its evolution over time. Discovery of a strange object. A peculiar discovery has captured the attention of scientists studying Mars. A donut-shaped rock, unlike anything seen before, has been identified by NASA's Perseverance rover during its exploration of the Jezero crater in Mars' northern hemisphere. This intriguing finding was captured by the rover's Remote Microscopic Imager, RMI, on June 22, 2023, marking the 832nd Martian day, or SOL, of the mission. On Mars, peculiarly shaped rocks are a common sight, resulting from prolonged periods of erosion, similar to what occurs on Earth. However, unlike our planet, Mars lacks the presence of water to facilitate waterborne erosion. Instead, the prevailing conditions on Mars lead to weathering primarily caused by wind and dust storms. This enigmatic donut-shaped rock adds to the list of curiosities that challenge our understanding of the red planet's geological history. Martian dust storms. The Martian dust storms have been observed and studied extensively by orbiters, such as NASA's Mars Reconnaissance Orbiter and Mars Global Surveyor, as well as rovers on the surface, like Curiosity and Opportunity. These storms can vary in scale, ranging from small local dust devils to planet-wide events that shroud the entire planet in a thick haze. The dust storms on Mars are driven by a combination of factors, including strong winds, the planet's thin atmosphere, and the presence of fine dust particles on the surface. These storms can be triggered by localized heating from the sun, which creates temperature differences and generates winds that lift the dust into the atmosphere. Once in the air, the dust particles can be carried by the winds and contribute to the expansion and intensification of the storm. Martian dust storms have a significant impact on the planet's climate and weather patterns. They can alter the temperature and pressure gradients in the atmosphere, affecting the overall circulation patterns. The lifting of dust particles into the atmosphere also influences the absorption and reflection of sunlight, which in turn affects the amount of heat reaching the planet's surface. As a result, dust storms can have both short-term and long-term effects on Mars' climate system. For exploration and colonization efforts, understanding and predicting Martian dust storms is crucial. These storms pose challenges to robotic missions, as the fine dust can settle on solar panels and hinder power generation, block cameras and sensors, and affect the mobility of rovers. They also have implications for human missions, as dust contamination can impact equipment, visibility, and even pose health risks. Night glows. Mars surprises us with its ethereal night glow, a faint illumination of the atmosphere even without direct sunlight. Chemical reactions in the upper atmosphere create this glow, offering insights into Mars' atmospheric dynamics and circulation patterns. The night glow's variations provide valuable information about winds at high altitudes and seasonal changes. This remarkable phenomenon deepens our understanding of Mars' climate and reinforces its status as a dynamic, complex planet. With each discovery, Mars unravels its secrets and showcases its potential as a habitat for life. As our exploration continues, we can anticipate further revelations about the Red Planet, fueling our curiosity and paving the way for future exploration and potential colonization. So, do you believe humans can colonize Mars one day? Share in comments, like, subscribe and watch more content like this here.